Okay, today we're talking about modeling with two variable inequalities. So our objective is going to be model and solve real-world problems using two variable inequalities. Before we do that, let's do a quick review, all right? On the previous lesson when we talked about one variable inequalities, for example, you have John earned at least 75 points on his test. Okay, so here, John's number of points X is the variable. Okay, so we can name it X, we can name it Y, whatever variable we want, but X is the common one. And here you see at least, that's your inequality. That's when you know it's an inequality, and 75 is the constant. Okay, so your inequality is going to be X has to be larger than or equal to 75, because at least means it could be 75 or bigger. Okay, so here, what are the possible number of points that John has earned? It says he earned at least 75, so it means he earned 75 or 76, 77, or 100, 150, or 1,000. Okay, we don't know anything else, but we know it's larger than or equal to 75. So it could be any of these or anything else, as long as it's more than 75. So to graph all of that, we need a number line, right? Because there are many solutions that we can choose from. So on this number line, we pick anything that is on the right side of 75. So 75 works, so we pick that. And then anything on the right side, 76, 77, 78, 100, 150, anything. So all those numbers together become so many that we just make a line for it, right? We darken the right side, and we put an arrow saying anything on the right side here is a solution. Okay, now keep that in mind as we go on to do today's lesson. All right, here's example one. We're going to be modeling with two variables now. So here's an example. To go to the movies, John and Sally need at least a total of $10. Okay, so this is way back when movies were cheap. All right, so here are my variables. X represent John's amount of money, and Y represent Sally's amount of money. Now, in this step, you can choose whichever to be X, whichever to be Y. It doesn't matter, okay? And I'm going to write my inequality. I know that total, they have to be at least $10, so X plus Y has to be larger than or equal to 10. And so what are the possible solutions here? Let's just think about it. They need at least 10. So if John has 5 and Sally has 5, that works, right? Or John has 5, Sally has 6, that's 11, that works. That's more than 10. Okay, so any of these 5 and 7, John has 5, Sally has 8. Or maybe John is flat broke, he has $0, but Sally has 10, that still works, right? Or John has 1, Sally has 11, that works. 3 and 15, that works. See, because there are so many, now we have to graph them because there's so many different solutions that it could be. So here I have a number line for John's amount of money, but then I also need another one for Sally's amount of money. That's why now I need the second number line. Now you guys see that it is a coordinate plane, right? That's where the coordinate plane comes from. It's two variable X and Y. All right, so here on the coordinate plane, I'm just going to plot all these numbers on here. 5 and 5, that works. 5 and 6, that works. 5 and 7, 5 and 8, 0 and 10, 1 and 11, 3 and 15. You see all these numbers work. How do we show all of the numbers that work? Okay, so the best way to do that is just to graph a line. All right, so to graph this inequality, what you do first is you're going to solve for y. Okay, so you solve for y. So now I have y is larger than or equal to negative x plus 10. I just subtract x from both sides. Now this is in slope-intercept form, so you can graph that just like a normal line. Okay, so you start at the y-intercept 10. So you go to 10, and then the slope is negative 1 right here. So you go down 1 and over 1. So there is my line. Now right here, the line should be solid or dashed. Okay. Now remember, if it has an equal sign here, greater than or equal to, and less than or equal to, you use a solid line. If it's just less than or greater than, you use a dash line. Now, why is that? That's a challenge for you guys to find out, right? Do a little bit of research. Look on YouTube, look on Google, see you can figure out why. Why is it solid or dashed? Okay. Now let's move on here. Let's think about this. Now, should there be negatives? You see how on this side it dips to the negatives, right? So John has negative $5 here, and that means Sally has to have a lot. It depends on each situation. Should it have negative or not? Okay, in this situation, I'm not sure. If John has negative dollars, that means he owes some money. So before they go to the movies, Sally has to give him money to pay somebody. It doesn't make a lot of sense to me. So it depends on each situation whether you should have negatives or not. Okay, but let's move on here. You see how all these points are on one side of the line and none of the points are on this side? That means that every point on this side of the line is a solution. Okay, as long as one point works, all the points work. None of the points on this side will work. Okay, if you put a point here into the x and the y, it will not work. Anyway, so you know this side will work. So instead of picking individual points, we're going to shade the whole thing in. So it looks like this. All right, you shade the whole side in. Everything is red. Everything is a solution. Everything on this side is a solution. All right, let's try another example. Here, to raise money to go to the movies, John is selling lemonade and root beer floats. He charges $1.50 for a cup of lemonade and $3 for a root beer float. John wants to pay for Sally's part, so he wants to make more than 15. Okay, so how many of each type would he have to sell? So they're asking for how many of each type, how many cups of lemonade, and how many root beer floats he has to sell. So those are variables, right? So let X represent the number of lemonades he needs to sell, and Y represent the number of root beer floats he needs to sell. Okay, so the X and the Y, you can swap them in these situations, right? It won't matter. All right, so here I know that the money from the lemonade and the money from the root beer float has to be larger than 15 because he wants more than 15. But the money from the lemonade can be calculated based on how much he's selling for each, right? So lemonade, he's charging 150. So 150 times the number of lemonade gives you the money for lemonade. So 150 times X plus 3 times Y has to be larger than 15. Okay? Then you can just solve for Y, and you have Y is larger than negative 1/2 X plus 5. Again, this step here is just solving for Y like you would in equations. Okay, if you need help on this, let me know, or let your teacher knows. So here I have that, and I'm just gonna go ahead and graph this. So X is my number of lemonades, Y is my number of root beer floats. On my coordinate plane, I'm gonna graph that line, and it's gonna be a dashed line because there is no equal sign here. And then to know which side to shade, I pick a point to test. Okay, if the point works, everything will work. If the point doesn't, then the other side will work. Okay, so I'm going to test 0, 0 because that's the easiest point to test. So test 0, 0. I put 0 in for X and 0 in for Y. So put 0 in for Y here and 0 in for X. I have 0 is greater than 5. And that's not true, right? So I tested 0, 0, and it's not true. So none of the points on this side will work. So I know that the other side will work. I'm going to shade the other side in. That means every single point on the side that is red is going to work. Okay, that's the solution. So here's a little summary for you guys here. The first step is to determine the two variables that you're looking for. That's when you do the step. Let X represent, let Y represent. Okay, write that down. Step number 2, write the inequality for the relationship between the two variables. All right, once you have the inequality, you solve for Y. Again, let me or your teacher know if you need help doing this part, solving for Y. All right, and then you graph the line. Make sure you know if it's solid or dashed. And then the last part is to test 0, 0 to know which side to shade. If it works, you shade that side. If it doesn't work, you shade the other side.